Hello everyone, today I will present our work in CVPR 2025 LOCORE imagery ranking with long context sequence modeling. Let's get started with some background. The task of image retrieval involves an input of a query image and a set of gallery images, and the output will be ordered list of a gallery image. When it comes to imagery ranking, we expect that such similarity metrics could be improved further rather than the shallow interaction at a very late stage, for example, the dot product between embeddings. To achieve that, a standard solution is to use cross-encoder that takes a pair of images simultaneously and produce a similarity score for this pair of images, just like we're seeing on the right side of the screen. However, we believe pairwise image ranker is still not optimal as it could not capture interactions between gallery images. Sometimes that matters a lot when we're dealing some hard cases. For example, here we are seeing a query image and two gallery images where the first pair of images are easy for the model as they clearly shares the same structure at the top of the tower. The second gallery image is also a positive pair, but hard to predict as the top of the tower is not clearly visible in the query image, in the second gallery image. However, we could see that both gallery images have the same window area that could be used to calibrate the prediction of the hard positive image, which we named it transitive relationship. So this motivates us to think that if we are able to model the query and all of the gallery images at the same time, so that we can capture such transitive relationships. Fortunately, we could utilize the off-the-shelf long context sequence model from the natural language processing community that could easily support thousands of context tokens. And then we apply token level supervision to the corresponding gallery image token, which is basically a binary label. And at inference time, the tokens associated to the same gallery image get aggregated to a single scalar score that represents the re-ranking model prediction to that gallery image. To make the training affordable, we enable global local attention by only applying global attention to these important tokens, namely all the query image tokens and all the separated tokens. Another technique is also important because when we are training the model with initial retrieval results, the positive images are gathered in the front of the ranking list, and we definitely don't want the model to learn from such positional bias. That is the fact that those images in the front are likely to be the positive. Finally, at the inference time, we expect the model to work on more gallery images than the number of images it was trained on. Therefore, we use a sliding window re-ranking technique to run LOCORE on overlapping groups of gallery images. This could be seen as an inference time scaling method that makes the model perform better as the inference compute increases. And LOCORE exhibits clear and consistent improvement over all local descriptor re-ranking baselines, and the sliding window re-ranking is used for re-ranking the top 400 candidates, which further boosts the performance. The qualitative example also shows that the model is working as expected by exploiting the transitive relationships among the gallery image to calibrate the predictions. And this will finalize our presentation. Thank you.